You should always try to unlock it in the finally so that no thread is kept on blocking indefinitely. So the important methods are lock and unlock. When the permits are exhausted, so you had 3 gate passes and now it has exhausted, comes back to 0. Then if you call acquire, of course you don't have any more gate passes available. Then if you call acquire, it will block the current thread until the permit is available. You don't acquire the lock. On running this is what we get. Initially thread 2 was not able to acquire it because thread 1 had acquired it. When thread 1 released, thread 2 will be able to acquire it. The Java docs of these classes are a little complex to understand. There's a lot of jargon. Now that is what we have tried to simplify in the form of this video by talking about in simple jargon-free words. Hi everyone, welcome to my channel Code with Ease by Varsha. We have been doing a playlist on threads and concurrency. These are the videos which we have already covered. So we have covered many different topics including deadlocks, synchronization mechanism, wait, notify, producer-consumer problem, as we can see. Today's video's topic is a little bit advanced. It is going to be on advanced synchronization construct. So if you are new to this topic, I would recommend to watch the videos in sequence of this playlist first and then jump on to today's video. So the biggest takeaway for you guys from this video is going to be you are going to understand in depth about Semaphore, about ReEntrant Lock, the differences between Semaphore ReEntrant Lock, and also the difference between the synchronized keyword, that synchronized block, and the synchronized methods that we have used so far. How is it different from the Semaphore and how is it different from the ReEntrant Lock? Like basically the use cases, when to use which one, what is the specific use utility or what is the specific use case of each of them. So all of this we have to understand, otherwise we will not know where to use a Semaphore or where to use the synchronized block or where to use a ReEntrant Lock. Each of them have a different purpose. So distinction between each of them is important to understand, and that is what exactly we are trying to do in this video. Secondly, the Java docs of these classes are a little complex to understand. There's a lot of jargon. Now, that is what we have tried to simplify in the form of this video by talking about in simple jargon-free words and showing relevant code snippets also wherever applicable. So with that, let's begin. So let's talk about semaphores. It is a thread synchronization mechanism which functions as a lock and it has a counter feature. So the traditional synchronization mechanism that we have seen, that is the usage of, let's say, the synchronized keyword which we use on a method or a block to protect a particular critical section of the code. There we didn't have anything as a counter feature. So what is this doing? Semaphore is also another synchronization construct only, where in case of a concurrent programming, you have multiple threads and you want to protect your critical section of the code from these multiple threads manipulating it at the same time so that no race condition happens. Otherwise, you'll get incorrect result. This is what we know. Multiple threads manipulating a shared resource and you want to control the access of these threads in a way, in a synchronized manner so that no race condition happens. This is what we are doing. How we are controlling using Semaphore? The main control mechanism comes with this counter feature. It maintains a counter. It maintains some kind of a permit. Semaphores are part of the java.util concurrent package. It's a class. It implements the serializable interface. Permits. Okay, so this is a keyword. The counter feature that we talked about, the way it is trying to limit the access of these multiple threads, it does it via the use of permits. Now what the threads do is, whenever the threads try to acquire these permits, they decrement the counter. Suppose I have counter of 3. I'll also show it with the code. So we have counts, like let's say the number of permits, the gate passes that you have is 3. When you acquire, you have acquired a pass, so your counter gets decremented to 2. And when you release, again the counter gets back to 3. So releasing means it will increment the counter. So when you acquire a permit, you decrement the counter. When you release, you increment the counter. So the threads are trying to increment or decrement the counter. There is a constructor of Semaphore which accepts a fairness parameter. Okay, so this is just an FYI that when we will see the constructor of Semaphore, if the constructor has a parameter which is either Boolean, false or true, if it is false, then it will not ensure the specific order in which threads will acquire the permit. Suppose you have 3 permits and there are 4 threads which are requesting. So you'll have the order like first thread number 1, thread number 2, thread number 3 and thread number 4. So in this order, the permits will be given. But if it is not there, like if it is true, then it will try to grant the permits in this order. But if it is false, then this order is not guaranteed that in the sequence in which the permits are being requested, in the same sequence, they are going to get also the permit. So it is just an FYI, just to tell you about this additional constructor. Okay, but the main concept of this particular slide was semaphore is a synchronization construct which helps to control the access of this multiple threads to a shared resource using a counter. Moving on. As we said, acquire is if the permit is available, it will acquire the lock and decrement the counter, and just the opposite, it will return back the permit and increment the counter. When the permits are exhausted, so you had 3 gate passes and now it has exhausted, comes back to 0, then if you call acquire, of course you don't have any more gate passes available, then if you call acquire, it will block the current thread until the permit is available. You are not going to be getting the permit, you will be waiting indefinitely. There are 4 types of semaphore. In this video, we will talk about the 2 main ones, binary semaphore, counting semaphore. So if you take a look at this particular example, we have a semaphore which has 2 permits. So you can imagine there are 2 gate passes that is available. When you acquire it, we know that the counter decrements. So 2 becomes 1. And then we are trying to print how many available permits are happening. So it should be 1. Then we sleep for 2 seconds and we release. When you release, it should get restored back to 2. Right? So this is how the acquire and the release method is working. We are also so this is what we are printing. Thread 1 trying to acquire, available permits is 1. When you release, it gets restored back to 2. So this is how the acquire and the release method is working. Moving on to the types, now we have binary semaphore. So like we discussed, we are going to discuss about 2 types, binary and counting semaphore. So binary, as the name suggests, there can be either 2 values, 0 or 1. When it is 0, you have no permits. If it is 1, there is only 1 permit available. So it is just going to flip between 0 and 1. Why is it necessary? It means that only one thread can access the critical section at any given time. So there's a subtle difference. In the previous example, it is more about limiting. It is more about controlling the access. If you have 3 gate passes, you are saying at a time only 3 people can enter and do the work. At a time, only 3 people can access the critical section. Here, there is only 1 thread which can access the critical section. So the difference is just having 1 gate pass and allowing only 1 person to enter versus having 3 gate passes and having 3 persons to enter. So that is a subtle difference. Now this is a code example for binary semaphore. You have 1 permit only, creating a binary semaphore with 1 permit. Now when we are doing the acquire and release, how is it working? When you're first trying to do the acquire, you have acquired it, so 1 goes down to 0. So that is why available permits is 0. Now when you try to release, you are again restoring it back to 1. You cannot do anything other than that. It will only be 0 to 1, 1 to 0. Moving on to the counting semaphores. Now what is this? The counter value is going to be greater than 1. In binary semaphore, that was exactly equal to 1. Counting semaphores is you have more than 1 permits, that is permissible. Allows a specified number of threads to access a critical section concurrently. If count 0, no access allowed. Greater than 0, access allowed. This is very intuitive. If you have more than 1 permit, only then you will be allowed to enter the critical section. If you take a look at the code example for this is similar to what we discussed in the very first example. We have 3 permits and we are trying to do acquire and release multiple times. So try to understand this carefully. If you are doing the acquire, now 3 becomes 2 because you have done the first acquire. Now again you are trying to do a release. When you try to release, it should again go back to 3. Again if you acquire, so it should go back to 2. Again if you release, it should go back to 3. So this is what we are trying to achieve over here, where you have the number of permits greater than 1 and your threads can acquire and release accordingly. Now the question that might come to your mind is when to use either of them. So when you have binary semaphore, as we see, there's only 1 entry pass. It is going to give you exclusive access. But in case of counting semaphore, multiple simultaneous access up to a specified limit. In case of binary semaphore, there is only 2 states, either you lock and unlock. Here, in case of counting semaphore, the scenario is that you have a fixed number, a small pool of resources. Like I said, I always take this example, 3 gate passes. There's only 3 available gate passes for you. So you have a fixed number of resources. In that case, you're going to use it. To sum it up, you are going to use binary semaphore to protect a shared resource so that you want only 1 thread to access it at a time. In case of counting semaphore, like I said, there should be a pool of resources and multiple threads are trying to use it, but you want to limit how many threads should be using that particular critical section of the code. So this is how we should be clear about what is the difference between binary and counting semaphore and where to use which one. Moving on to the next section, that is, we'll talk about ReEntrant Lock. Now we'll talk about the lock interface before we talk about the ReEntrant Lock, because ReEntrant Lock is a concrete implementation of the lock interface. So it is part of the Java util concurrent.locks package. Alternative to synchronized word, today whatever we are discussing is an alternative to the synchronized keyword, the synchronized method, or the synchronized block that we have seen so far. Now starting with the first method, which is the lock method. So basically there are two methods which we have to understand importantly: lock and the unlock. Okay, so lock method, what it does is it will lock the resource if it is available. Otherwise, it will block the thread until a lock is released. What it means? You have a door. Okay, you want to access this particular door and go inside the room. Now the door is locked. If the door is locked, of course, you will not be able to lock it again. Unless the door is unlocked, only then you'll be able to get into the room. So what it is saying is you can lock the resource. If the door is open, you can lock it. But if the lock is already done, if the door is already locked, you will have to be waiting. So that is, it is going to block the thread until the lock is released or until the door is unlocked. And unlock is going to release the lock. So the concept is, before entering into any shared resource, you have to acquire the lock first. And then once you are done with the work, you're going to unlock it. Always remember, the unlock should be always available in the finally block. Like once you're done with this, no matter what exception happens or what, finally is always going to execute. So you should always try to unlock it in the finally, so that no thread is kept on blocking indefinitely. So the important methods are lock and unlock. And the common implementation of lock interface is ReEntrant Lock, which we are going to discuss. Lock, as the name suggests, there is a re-entry mechanism which is happening. It is also known as recursive lock. So what is this re-entry going to be about? So in this case, it's a recursive lock providing mutual exclusion find. Reentrant here means the threads can reacquire the lock without causing a deadlock. Have you ever seen this happening in the previous concepts on synchronization, that once you've already acquired a lock, can you relock it? You cannot. So this is the speciality of this kind of lock, where you have to relock it. Like you have to acquire the lock multiple times, then you can use this reentrant lock. Next question which comes to the mind is, why do you want to reacquire a lock again and again? We'll come to that. So here also we'll use a lock method like we discussed, coming from the lock interface. We'll acquire the lock. Now, like in Semaphore, we had that mechanism of acquire and release. In this case, what is happening is, when you try to acquire, the thread counter increments by +1. Like you have got a hold of the lock. Now the lock count is increased by 1. And when you release it, it decrements the counter. We'll see a code example shortly. Now the threads must request the same number of unlocks to release. So you have locked it twice. Okay, you have locked a particular resource twice. You also have to unlock it twice. Only then you will be able to release the resource. It is useful in scenarios where the method or the code block might call another method that also requires a lock. Like in case of nested method calls, you have one method, you're calling this function. Now function internally is also calling another method. So you want to have a lock on this particular resource also. And once you go inside, so once you got hold of the shared resource over here, then you called your lock over here. Again, when you went inside the function, then also you have to acquire the lock, because you want to hold a lock on this particular shared resource also. Means you want to acquire this, access this shared resource. So you're locking it twice. Now, since you're locking it twice, you also have to unlock it twice. Remember that. So this is about the mechanism of the re-entry and why the name of it is come to be ReEntrant Lock. So now let's see a code example. See this code. So we have the ReEntrant Lock. Now we are locking it twice. There are 3 methods which is useful. One is the boolean is locked, if it is locked or not. If the lock is held by current thread, and the hold count. So if you try to print this out, what are we seeing? If it is locked, we are seeing it is true. If it is held by the current thread, then also we see that to be true. Now we have called lock twice, but we have unlocked it only once. Because we have unlocked it only once, because of that, what is happening is the lock is still held. So that is why again you're seeing true, is locked, is true. But when we print the hold count, we see it is 1. So it is something like you have 2, the counter. You have twice locked it twice, count is equal to 2. I mean the hold count is equal to 2. Then you called only unlock once, so it came down to 1, which is why you're seeing 1 as the get hold count. You again try to lock it. Now it increments. Remember, lock is going to increment the counter, unlock is going to decrement the counter. So now again the counter is 2. Again you called the unlock over here. Because you called the unlock over here, again the counter came back to 1. Now when you're printing, it is still locked. Yes, but the hold count is coming to be 1. Now again you unlock it. Now when you unlock it again, now the counter becomes down to 0, because you have locked it twice, also you have to unlock it twice. So that's why at the end, when you're seeing if it is locked, it is returning false. And when you're getting the hold count, it is returning 0. So this is how the lock and the unlock is working, and how we are able to see it by using these methods. The get hold count is important. we are also able to see whether it is locked or not locked. So this is how the lock and unlock is working, and we can understand by using these methods whether the lock is still being held and how much is the counter value. So now let me also show you the code, I mean the class for ReEntrant Lock. So this is the class for ReEntrant Lock. This is the class for ReEntrant Lock. Okay. Like we said, it is implementing the lock interface and the serializable interface. And there's a lot of different information over here. So we'll see the constructor. This is the constructor which we just now used, and the one which takes a Boolean parameter of fairness, like we have seen in Semaphore, to ensure the fairness. This is a lock method. This is a lock method. So here it is written that it acquires the lock, and it acquires the lock if it is not held by another thread, returns immediately. So all of that we have already covered in more simpler words, because the Java docs, as we can see, is a lot of documentations and it is not very easy to understand. So this is why we have brought out this particular video, where we try to discuss the most important aspects of ReEntrant Lock in more jargon-free language, in more simple words. So you can also go through this particular ReEntrant Lock class. It is part of Java Util Concurrent Locks package, and go through this to understand it more deeply. Let's move on to another aspect of ReEntrant Lock. And that is tryLock. Okay, so this is another method. So what tryLock does is, as the name suggests, it is going to try before acquiring the lock. So it is a non-blocking variant of locks. Why is it called non-blocking? Because we have seen that door example, that if the door is already locked, you cannot lock it again. The door is already locked, another thread cannot come in and lock it again. It will have to wait. So it attempts to acquire the lock without waiting if it's currently held by another thread. So that is T1 and T2. T1 is already holding the lock and it can lock it multiple times. We know that. But if T1 is trying to hold the lock, it is not able to, because it is acquired by T1. But it is a non-blocking variant. So if it T2 does, instead of lock method, if it does a tryLock, it will not have to wait. If it calls the lock method, it will have to wait. So it returns a Boolean value to make it simpler, to true or false. If it returns true, means the lock is already held by another thread. Otherwise, it is not. If the lock is not available immediately, thread does not block, it continues with the execution. This is in contrary to what was happening. Initially, we said that if it is trying to acquire a lock which is held by another thread, another thread is going to get blocked and be waiting indefinitely. But if it does a call, if it tries to call the tryLock, it will not get blocked and it is free to do whatever it was executing. tryLock also has a time unit parameter where it waits for a certain number of time, like certain timeout, before giving up the attempts. So it will try to keep on acquiring the lock. Is tryLock available? Like, is the lock available? Is the lock available? Now it will do so for some amount of time. After that, it will give up. It will not try to acquire it. Useful in scenarios where we want to acquire a lock, but we do not want to wait indefinitely if it is held by another thread. Right, so it is just like you're trying to check. It's like a condition check which you're doing. Instead of trying to forcibly acquire the lock, you just want to see whether the lock is available or it is not. If it is not available, you go on with the other execution. So if we see the code in the ReEntrant Lock class, this is the tryLock. Again, a bunch of different information, a lot of things are given. Here the time unit thing is mentioned. Here it is saying that acquires the lock only if it is not held by another thread at the time of invocation. And this is returning a Boolean. If the lock was free and acquired by current thread, it will return true. Or if the lock is already held by another thread, it is going to return false. So it's a good way to check if the lock is free to be acquired or the lock is not free to be acquired. Okay, so moving on. Just a small code demo. There are two threads, and here in this way we are trying to see. We are using if statement because it is returning a Boolean. If the tryLock, we just try to invoke this. If it returns true, we will get into this block where we'll say that the thread is acquired. And of course, we'll try to unlock in the finally block. Else, if it is returning false, means it is held by another thread, then we will say the thread couldn't acquire the lock. On running this is what we get. Initially, thread 2 was not able to acquire it because thread 1 had acquired it. When thread 1 release, thread 2 will be able to acquire it. Now we'll start wrapping up by talking about difference between Semaphore and ReEntrant Lock. We know that Semaphore is more of a controlling mechanism. It has the number of limits or permits, and in that way it is trying to control the access to a shared resource. ReEntrant Lock has a completely different purpose. It is no controlling or limiting mechanism. It's more like re-entry mechanism, where you want to reacquire the lock again and again by the current thread. Non-reentrant, again, same thing. Semaphore is not having that mechanism at all. So they are completely two different verticals, Semaphore and reentrant lock, right? Now, in case of Semaphore, any thread can call the acquire and release. We know that if the limits was three permits, so any one of them can call the acquire and release and modify it. But in case of reentrant lock, there can be only one thread which is currently doing the lock, and of course the unlock later on. And in between, if somebody comes, they will not be able to. We have seen that in the tryLock thing also. If it uses a tryLock, it will be able to get the message that it cannot lock it, so continue with its own execution. Otherwise, kept on waiting indefinitely. Scenarios of usage, because the purpose is different, the scenarios are also different. In case of Semaphore, where limiting the concurrent access is necessary, like a fixed pool of resources. Like suppose you have DB connections and you want only three at a time, only three connections to the DB, not more than that. You can use a Semaphore. But in case of reentrant lock, you have multiple nested method calls wherein it starts with one flow and goes inside another flow. It's a nested call. And while it does that, it has to acquire the lock on every different type of critical section of the code. So in that case, you will have to acquire the lock again and again. Now talking about the difference between reentrant lock and the synchronized keyword. So reentrant lock is giving you more fine-grained locking, but differences between reentrant lock and synchronized keyword. Reentrant lock, as we can see, there's so many different layers of functionality, which is why it is able to give a fine-grained locking. But synchronized keyword is very much coarse-grained. Like it doesn't have so many layers and specifications and features that we have already seen in case of reentrant lock. Explicit lock acquisition. Do we have anything in case of synchronized keyword? No. You enter the synchronized block and you don't know what is happening at the inside it. You only use a wait and notify to control, like to do the inter-thread communication. That's it. Who is acquiring the lock? How many threads are acquiring? Nothing we know. But because of the methods, like we have seen, is locked. Then we saw that get hold count. It is giving you more control over the locking mechanism, contrary to synchronized keyword. Possible to call unlock and lock and unlock in separate method, but synchronized block, it cannot go beyond a single method. Whatever you have to do inside one method only. tryLock. Why fine-grained thing is coming? tryLock can be used, but is there anything equivalent of tryLock in case of synchronized keyword? No. All the other threads which are trying to get the lock, they are blocked indefinitely. But there is no way to continue with another execution if they're not able to get the lock, which we have that flexibility when we use a tryLock. Programmer is responsible for acquiring and releasing the lock, but in this case, JVM is responsible. So on the whole, fine-grained locking, more functionality is what we get in reentrant lock, which we don't get in synchronized keyword. And we are going to wrap up today's video. It has been a really lengthy video for today, and we are wrapping up today's video. So thank you so much for watching. Hope you guys have got a very good idea about synchronized keyword, reentrant lock, Semaphore from this video, and you will also be able to now understand the Java docs of the same. So spend some time on going through the Java docs of the same. And thank you so much again. And thank you again for watching. Please don't forget to subscribe to the channel if you haven't already, and like and share the content and share it with your peers, whoever might find it useful. Like and share. Do like the video, leave a comment. It just gives us a boost of motivation to bring out more content like this. Thank you so much.